Hi everyone, this is our new lecture in which we will design the microstrip patch antenna which will operate on 13 GHz. As we have seen in the previous lecture, that by using the parametric analysis and analytical approach, we calculated the dimension of the patch. As you can see here, this antenna was operating at 13 GHz and we knew the substrate size and the thickness of the substrate. So from that we calculated the width of this patch and the length of this patch. So in this lecture we will design this microstrip patch antenna in the CST Studio, and then we will use the parametric sweep to tune this antenna at 13 GHz. So in order to design that antenna, we will go to the CST Studio. So we will open the project template and then we will select the RF opticals. From that we will select the antenna. Then we will select the planar patch and click on next, next, and then finish. And this window will be open where we will design our microstrip patch antenna. So depends upon your choice. You can design the substrate plane, ground plane, or the patch first. So first we will design the patch. For that we will go to the modeling section and we will open the brick. As you know in this slide that we have analytically calculated the length and width of the patch. So we will select the brick, press the escape button, and I will write patch here as a name. Minimum x will be minus w by 2 and w by 2 will be the x max. Y min will be minus l by 2 and y max will be l by 2, and z max will be the CT, which is the copper thickness, and we will select the material as copper from the library. So in the library write copper, and every time the patch will be of copper material, so always select this copper and then load it. Now we will make a preview. As we have calculated, the width is 7.14 and the length was 5.1. So you can see here the width and length which was previously calculated through parametric equations. Now I will write the description as length, and then I will write length of the patch. Click OK. CT is the copper thickness, which is 0.035 copper thickness. Click OK. Now you can see there the patch has been created. I will click OK. So first I am going to just make a round value. The width is 7 and the length is selected as 5. I am going to remove the decimal value. Then I will go to the home and I will write the parametric update. I will either click on F7 or just click on parametric update. So here I will write the description of this parametric list, which is the width of the patch. So I will write the width of the page. I have changed these values. I'm not going to take 7.14 or 5.1. I'm going just to take the round values because I will be using parametric sweep through which I will select these dimensions so that our antenna could operate on the desired frequency. So after I have designed the page, now I need the feed line. So in order to make the feed line, I need to know the middle point of the page. So press on the M, and then after pressing the M, click on the middle point of this page. So here you can see this is the middle point. So here I will create the feed line. So double click on it and then click on W so that coordinate should switch into this point. Now I have created the I have shifted the coordinate to the middle point of the page. Now I will draw the feed line, go to modeling, select the brick, and then after selecting the brick, press escape, write feed lines here. After that we will calculate the length of the feed line. So there is a general trick that always the length of the feed line should be half of the page width. So this is a general trick which we used while creating the feed line. So we select the length of the feed line as half of the page width. Since the page width is 7, so the length of the feed line should be 3.5 at this point. So we need to write the page length is 3.5 here. In the ymin and in the ymax we will write values. So there are two methods, either create a feed line as a variable. So I will write fl by 2 and fl by 2, but the ymin will be minus fl by 2, so that it may be centered around the origin. And the width of this feed line would be selected as fw. So I will write fw by 2 at both sides, and so it should be minus here. The first value should be minus. It should be minus fw by 2. Then I will click on the preview, and you can see here we have the value. So the length is 5. The feed line, the page length is 5. So here in the feed width I will write 2.5, since this is the half of the page length. So I will write the feed width here, click on OK. Then the feed length should be half of the page width, so it would be 3.5. I will write 3.5 here, and then in the description I will write the feed line length. Click OK, and then we need to select another type of thing, which is the CT. This is the thickness of the feed line. Then we need to assign material to this feed line, which would be copper, as the copper has already been selected, so we don't need to change it. Now you can see as the feed line is not at a proper position, so I need to shift it to the origin. So I will write some values here, so that I will write minus 2.5 and FL. In the preview you can see that it is not properly aligned with the page, so I need to shift it properly. So I will write FL minus 2.5. Still it is inaccurate. Since the length of the width of the page is 7, so it should be 3.5 here. So I will write minus 3.5 to FL minus 3.5, so that it may be shifted to a value of 3.5. Now you can see that the feed is at proper position. It is aligned with the page and it is at the proper position, so we will select OK. Now I will remove the axis by clicking here. The axis has been removed. I will zoom it and to see that and we can see that this is not properly aligned along the z-axis. The page is lower than the feed line. The feed line is above the page along the z-axis, so I need to shift it along the z-axis towards minus z-axis. So I will click on the feed line. I will go to the its properties, and I will write minus CT here. And now you can see that the feed line is aligned to the page along the z-axis, so I will click on OK. Now you can see that it is properly aligned. Now I need to join both of these, like the feed line should be connected with the page. So for that I will go to the feed line. I will select the feed line and press the control, select the page, and then go to the boolean and click on the add. And you can see that they are now connected. So the page and the feed line is now connected. They are both working as a single component. Now I will select the brick to design the substrate. So to define the substrate geometry, I will, in the xmin, I will write the width of the substrate, which is here. The page width is 7. So I will write SW here, SW mean the substrate width, but it should be from minus SW by 2 to SW divided by 2. And the length of the substrate, I will write the variable for that as well. So the length should be covering the feed line and the page both. So I will write the SL for the substrate length. So there is a variable which I should define for that. So I will write SL for that. Now we will further decide the dimension of the page through parametric sweep. But now at this moment we are going to identify to assign the value of the page length, the substrate length at this moment. So we know that the page dimension is 5. 5 is the page length. So half of the 5 is 2.5. From this point to this point we have a value of length which is 2.5, and then the feed line length is 3.5 from here to there. So 2.5 plus 3.5 makes a value 6. So double of this is 12. So it should be 12, like the width of the length of the substrate should be 12. So here we will write in the SL by 2 minus SL by 2, and in the Y max we will write SL by 2. And similarly in the Z max we will write the thickness of the substrate, which was ST. Now we will assign values to these variables. SW is 10 and SL is 12, and the thickness of the substrate is 1.57, which is thickness of the roger. Now you can see that we have created the geometry of the substrate. So this is the geometry of our substrate. And we can see that the substrate is about the page. So I will zoom it and I will rotate it to see that where is the substrate and where is our page. So now I need to shift it along the z-axis. So I will write minus ST here, and in the preview you can see that now the substrate is below the page. And one thing which I skipped is that I have not assigned the material to the substrate. So I will click on this. I will right click on here on the substrate, and then I will go to the change material. And as we know that the material for this should be FR4. So here we have to use the FR4. So I will write the FR-4 and I will click the FR4 lossy. Click on load and then click on OK. Now you can see that the material has been loaded to the substrate. Now I will zoom it to see the side view of this substrate and the page. So you can see here, I will zoom it. You can see that this page is above the substrate. After creating the page and the substrate, now I need to create the ground plane. So for that I will go to the modeling. And again I will select the brick, and then I will go to the properties of this. I will write the ground plane, and the width of this should be similar to the width of the substrate. So I will write minus SW divided by 2 to SW by 2, because the substrate and the ground plane width should be similar, and the length of these two should also be similar. So I will write minus L by 2 to plus SL by 2, and we should note that it should be below the substrate. It should be below the page and substrate. So I will write minus ST minus CT. And here for the Z min I don't know what should I write, so I will write minus CT. And now in the preview we can see that it is not at a proper position, so I need to change this value. I need to change this as minus ST. And now in the preview we can see that the ground plane is below the substrate. So here we can see that this is below the substrate. I will select the material. I will load copper because the ground plane should be made of copper. After that I will zoom it to see that where is the substrate position, and you can see that substrate is below the the ground plane is below the substrate. So now I will verify the dimension. I will zoom it, press S, and then click on this side, and you can see in the pick element that it is 0.035. So it means that the thickness of the ground plane is correct, which is equal to the thickness of the copper. Now I will verify the dimension of the substrate. So I'll click on S. I will click on this side, and you can see that it is 1.57, which is correct as we have seen in the slide. Now as I have created the complete geometry of the microstrip patch antenna. Now after finalizing the geometry, I will start a simulation, but before starting the simulation I need to create a port. So for the port, I will zoom this section and I will select the middle point of the patch lower edge. So I will press on M, or you can select pick edge center from here. So you can press M from the keyboard, and you need to select the middle point of the patch of the feed line, but the middle point should be, the edge should be selected, the lower edge should be selected like this one. So after selecting the lower edge, I will press W from the keyboard so that the X edge should be switched to this selected point. So in your keyboard, W is for shifting the axis, S is for the selection, and D is for the deselection. So M is for the midpoint. So you have to use these keys in the keyboard frequently. So now I'll click on W and the axis has shifted to this point. Now I'll go to the simulation. I will select the discrete port, and in the WN I will write -ST, which is the thickness of the substrate. So I will preview it, and you can see that the port is properly connected. So I will zoom out it to see that how it is aligned. Now you can see that the impedance is 50, which is fine. So I'll click on OK. Now I have created the feed point. I will go to the modeling and click on W so that the axis should be switched back to the previous point. Click on the port 1 here from the port section and zoom this place. Now as you can see here, after zooming it, you can see here that the port is directed from the ground plane to the patch. So you can see the arrow is from the ground plane to the patch. So this should always be like this. I will go to the component and I need to change the name of this because it is the patch. So I will rename it. So I will rename it and I will give it a new name, which is the patch. So you can rename it from here, right, patch. Now after that I will start the simulation because everything has properly been defined. All the component of the patch antenna and their geometry has been properly defined. So now I will start the simulation. Now as we have created the geometry, we don't know that whether this antenna will give us the S11 at their desired frequency, but we should use the parametric sweep as well, because through analytical approach, through expressions, we calculated the dimension of the patch, but we to further tune it to the desired frequency, which is 13 gigahertz, we will apply the parametric sweep at these two variables, which is W and L, which is the width and length of the patch. So these are our different parameters. I will write the name of SL as substrate length, and SW is the substrate width. So I will write the name of the SW as well. So after creating the geometry, we need the parametric sweep as well, because the analytical approach, which is the calculating the dimension of the patch through equations, it gives us a rough value which is not 100% accurate. It gives us a rough value, and the rough values were 7.1 and 5.1. So we need the parametric sweep to calculate the precise dimension of the page, and to know that to design our antenna for the 13 gigahertz frequency, or to fine tune it at 13 gigahertz frequency band. So in the next lecture I will explain you more.